digraph or directed graph. Digraph or directed graph. So one example, see. Suppose this is vertex V1, this is V2, V3, this is vertex V4. This is one graph. See all the edges from V1 to V2. Suppose this is edge E1, this is E2, E3, this self loop E4, this is E5. Take one more edge, suppose E6. This is E6. Okay. See here the edges E1, E2, E3, E4, E5, E6. All the edges have direction. So a graph is digraph if all edges have direction. A graph is digraph if all the edges have direction. See, this is one graph G having 4 vertices V1, V2, V3, V4, edges E1, E2, E3, E4, E5, E6. This graph is digraph, all the edges E1, E2, E3, E4. So all the edges have direction. Okay, so this is digraph. Now, in digraph, suppose what is DG plus V1, DG plus V. Suppose DG plus V mean incident degree of this vertex V, out degree of this vertex. DG plus V mean out degree of this vertex V. Okay, that is number of edges incident out from vertex V. Number of edges incident out from V. Okay, number of edges incident out from this vertex V, that is out degree of the vertex. Okay, so what is out degree of this vertex V1? So DG plus V1, DG plus V1, number of edges incident out from vertex V1. So from V1 vertex, see incident out, the edge E1 is incident out from V1, but edge E5 is incident into V1. So number of edges incident out from V1, it is 1. Okay, DG plus V, that is incident number of edges incident out from V1. Now what is DG plus V4? Number of edges incident out from V4. Number of edges incident out from V4. It is here, it is E5, also E4. So 1 plus 1, it is 2. Okay. So incident out from V4, that is out degree of this vertex V4, DG plus V4, that is number of edges incident out from V4, 1, E4, E5 and E4. These are two edges incident out from V4. So DG plus V4, that is out degree of this vertex V4 is 2. Okay. Out degree of this vertex V3, out degree of this vertex is 1, 2. Out degree of this vertex V3 is DG plus V3 is 2. Now DG plus V2, out degree of this vertex V2 is 1. Okay. Only one is incident out from V2, that is E6. Now what is in degree? DG minus V, that is number of edges incident out from V. Number of edges incident out from V, that is out degree of the vertex. Out degree of the vertex V, DG minus V, that is out in degree of the vertex V, number of edges incident into V. Sorry, what is in degree of vertex, in degree of a vertex in a diagram? That is number of edges incident into V. Number of edges incident into V. Number of edges incident into V. That is in degree of the vertex. Okay. So in degree of a vertex V is number of edges incident into V. G minus V1. The in degree of this vertex V1, number of edges incident into V1. That is only one is E5 is incident into V1. So DEG minus V1 it is 1. Now DEG minus V4. DEG minus V4 number of edges incident into V1. See E3 is incident into V4. E3 is incident into V4. Similarly E4 also incident into V4. So DEG in degree of vertex V4 it is 2. E3 and E4 both the edges incident into V4. So in degree of this vertex V4 it is 2. So degree of any vertex DEG V equals to out degree of the vertex plus in degree of the vertex. DEG degree of any vertex is in out degree of the vertex plus in degree of the vertex. So what is the degree of this vertex V4? DEG V4 equals to DEG V4, that is out degree of this vertex. Out degree of this vertex it is 2 plus in degree of this vertex V4 it is 2. So 2 plus 2 it is 4. So degree of any vertex is in degree of the vertex plus out degree of the vertex. So number of edges incident out from V4 it is 1 plus for self loop take 1 plus 1 it is 2. Now in degree it is for E3 and E4 1 plus 1 2 it is 4. That's why for self loop we count twice. Okay. So this is in degree and out degree of digraph. Okay. Incidence matrix of digraph. Incidence matrix of digraph. Okay. Incidence matrix of digraph. Suppose the incidence matrix is A equals to Aij m comma n. So number of rows m, number of column n. So for this is the incidence matrix of digraph. So m is number of rows, that is number of vertices, number of vertices. N is number of edges. Okay, so this is the matrix, incidence matrix on digraph. M is number of vertices, N is number of edges, and Aij equals to 1 if Ej edge Ej is incident out from Vi. Okay, Aij equals to 1 if the edge Ej, that is jth edge, is incident out from ith vertex. This is minus 1 if edge Ej is incident into Vi. Okay, this is minus 1 if the jth edge is incident into ith vertex, and this is 0 for all other cases. For all other cases, that is if the edge Ej is neither incident into nor incident out from Vi. Okay, so Aij equals to 1 if Ej is incident into Vi. It is minus 1 if Ej is incident into Vi. 1 if Ej is incident out from Vi. Incident out. This is for incident out. If the edge Ej is incident out from Vi, then plus 1, minus 1 if incident into Vi. Okay. This is 0 if Ej is neither incident out nor incident into Vi. Okay. This is for incidence matrix of diagram. Now take one example. See one example. Suppose this is vertex V1, V2, V3, V4, V5. This is this is edge E1, this is E2, E3, E4, E5, E6, E7. This is the graph G having 5 vertices V1, V2, V3, V4, V5 and 7 edges E1, E2, E3, E4, E5, E6, E7. So the corresponding incidence matrix has order 5 cross 7. 5 vertices, 7 edges. Okay, so write V1, V2, V3, V4, V5. Right here E1, E2, E3, E4, E5, E6, E7. Okay. Now see edge E1. E1 is incident out from V1. E1 is incident out from V1. E1 is incident into V5. E1 is incident out from V1. So write here 1 and it is into V5. So in right here -1. For all other cases it is 0, 0, 0. E1 is incident out from V1. E1 is incident out from V1. E1 is incident into V5. So write here 1, write here V5. So E1 incident out from V1, write here +1. E1 incident out from V1, V5 incident into V5. So it write here -1. Next E2. It is incident out from V1, so write here +1. Incident into V2, so write here -1. For all other cases, it is 0, 0, 0. Next E3. See E3. E3 incident out from V2, so write here +1. Into V5, so write here -1. For all other cases, it is 0, 0, 0. E4. E4 incident out from V2 into V4. Out from V2 into V4. All other cases it is 0, 0, 0. E5. E5 incident out from V2 into V3. So +1, here it is -1. Right here 0, 0, 0. E6. E6 from V4 incident out from V4 into V3. So in V3 it is -1, in V4 it is +1. For all other cases it is 0, 0, 0. Now E7 incident out from V4, incident out from V4 into V5, right here -1. All other cases it is 0, 0, 0. Okay, so this is the incidence matrix of this diagram having 5 vertices, 7 edges. Okay, just write vertices in rows and column write the edges. Now E1 incident out from V1, so write here +1 into V5, so write here -1. For all the cases 0. Okay, so this is the incidence matrix. Next, adjacency matrix. Adjacency matrix. Adjacency matrix of diagram. Adjacency matrix of diagram. Okay, suppose the diagram adjacency matrix is A equals to Aij m comma adjacency matrix is square matrix n comma n or m comma m by m cross m. So adjacency matrix of diagram, it is square matrix having m rows or m columns. So m is number of edges. Okay, m is number of vertices. Aij equals to 1 if Aij equals to 1 if the edge incident out from V1, if the edge incident out from Vi and incident into Vj. Okay, Aij equals to 1 if there is an edge from Vi, from incident out from Vi, incident into Vj. This is 0 for all other cases. For all other cases. Okay, the element Aij equals to 1 if the edge incident out from Vi and into Vj. So it is 1 if there is an edge incident out from Vi and it is incident into Vj, and it is 0 for all other cases. Okay, now we will create the adjacency matrix of this graph. Now for this graph we have 5 vertices, so right here V1, V2, V3, V4, V5, right here V1, V2, V3, V4, V5. Adjacency matrix is square matrix, so write V1, V2, V3, V4, V5, right here V1, V2, V3, V4. This graph has 5 vertices. Okay, is there any edge which is incident out from V1, incident into V1? So is there any self loop at V1? No self loop, it is 0. Incident out from V1 into V2, out from V1 into V2. We have one edge, so right here plus 1. From V1, out from V1 into V5. So right here plus 1. For all other cases, it is 0, 0. So from V1 to V2, we have one edge. So right here 1. V1 to V5, you have from incident out from V1 into V5. Right here plus 1. Okay, from V1, incident out from V1 into V2. So here plus 1. From V1, incident out from V1 into V5. Right here plus 1. For all other cases, it is 0. Okay, now V2. Incident out from V2, incident out from V2, V2 to V3. So V2 to V3, 1, V2 to V4, 1, V2 to V5, 1. For all other cases, it is 0, 0. Okay, now V3. Incident out from V3. Incident out from V3, there is no edge. Incident out from V3, there is no edge. So for all cases, 0, 0, 0. Okay. Now incident out from V4, incident out from V4 we have E6, that is V4 to V3, V4 to V3 1, V4 to V5 1, V4 to V3, V4 to V3 1, V4 to V5 1. For all other cases 0, 0, 0. Okay, now incident out from V5, there is no edge incident out from V5. So there is no edge from V5. Incident out from V5, there is no edge. So for all cases 0. So this is the adjacency matrix of this diagram. Okay,